Okay, so let us go to question number 3 again, which we did in video 1, because this is very important, so we're doing it. Let's write it quickly. Law of constant proportion. Okay, constant or definite. Some textbook will call it definite. Constant, sorry. Constant proportion. Okay, we want to do it in a slightly different way so that we get the concept very clearly. The previous video we have done, but now let's do it in a different style again. First one is also correct, but this also will help you. For example, to explain this law of constant proportion, which says in a chemical substance the elements are always present in definite proportion by mass. Definite proportion by mass, what does that mean? Suppose you take here, if this is your water, okay, water, let us say, whose formula is H2O. So that is, here, see, just write along with me, that is hydrogen, there are 2, so write your 2 into, let's make it long, okay, 2 into, go to page 37 of your textbook, and there, hydrogen, what is the mass here? 1, so you write there 1 gram, plus your O1 at the back, so write 1 at the back of O. Nothing is there, means 1, no? This 2 doesn't belong to O, it belongs to the one in front, H. So if you go to page 37 again, O is oxygen 16. So this is the total mass of one H2O, that means one molecule of H2O. That is 2 ones are 2 plus 16 into 1, 16, so 16 plus 2. So one molecule is having 18 grams. If water, that is 18 gram, is decomposed, the word decomposed means broken down separately, means H2 and O are combined to form water. If you break that hydrogen and oxygen, separate them, then it gives equal to here, just take this one separately, 2 into 1, just now we saw hydrogen is 1 gram of hydrogen atom, and or is 2, here 1 oxygen at the back, into 16 gram, which means it will give 2 gram of hydrogen, and or is to 16 gram of oxygen. So we learned that when we break up 18 gram of water, we get separately 2 gram of hydrogen and 16 gram of oxygen. We will, law of definite or constant proportion means we will never get 2 gram of hydrogen and 20 gram like that. 18 grams, see, 18, 2 plus 16, 18. So when 18 gram of water is broken, we get 2 gram of hydrogen always with 16 gram of oxygen. We will not get, for example, 2 gram of hydrogen with 32 gram, or we will not get 1 gram of hydrogen with 16 gram like that. It will be fixed 2 is to 16 when 18 gram of water is broken. In other words, that is, if 9 gram, instead of this, so we can just do it here, cancel this one, 2 ones are 2 gram of hydrogen is 2, 2 8s are 8 gram. So if you cancel to the lowest number, 1 gram of hydrogen will be combined with 8 gram of oxygen. When you take 8 plus 1, 9. Okay, 9 gram of water is decomposed. So when 9 gram of water is decomposed, we will get 1 gram combined with 8 gram of oxygen. Never 1 gram of hydrogen combined with 9 gram or 10 gram. No, it's a fixed number. Okay, that is the meaning of law of constant proportion. Okay, so we go to the next question, and the next question is very important, question number 4. Go to your note and let me read the question. Here, Okay, before go to next question 5, we go to 4. Law of constant proportion stated was given. This law that we studied just now in 3, question 3 was given by the scientist called Proust. Yes, so tick there, yes. Next question 5. Write the postulates, means the word postulates means the main points, okay, of Dalton's atomic theory. This is a very important theory because this is the first theory given by a scientist. 4, so it's 5, not 4. Question number 5. Also write down question number 5. So write down the heading Dalton's atomic theory. Okay, point by point. Postulates means main points. Now 1, let me read that and explain it. All matter is made up of very tiny particles called atoms. To explain that, let us take matters or substances. Example 1, water. You take very common one, we will do formula, you write. So what are the atoms here? The atoms here are hydrogen, one type. So water is made up of hydrogen and oxygen atom only, nothing else. That is what is meant by the first point of Dalton's atomic theory, that all matter is made up of only tiny particles called atoms and nothing else. No other thing makes up matter except atoms. Okay. Another example you can take the air that you breathe. Formula is O2, no? It contains the atoms are, what are the atoms? Oxygen. It is made up of oxygen atoms only, nothing else. It is not made up of any other thing but atoms only. Again, another example, if you want to take sodium chloride, very common, so I'm taking it. This is the nimok we eat, no, salt, called in English salt. Formula is NaCl. So what is it made up of? What are the atoms in nimok that we eat? Very important. Sodium atom and chlorine atom. Again, it is made up of atoms, nothing else. So that's what the first point is saying. Every matter in nature is made up of only atoms and nothing else. And these atoms are tiny, indivisible particles, very tiny particles. Point number 2, go to your note. And here it says, atoms are indivisible particles which cannot be created nor destroyed in a chemical reaction. So to explain that, still looking there, you just look at this example, easily understand. So we'll take the reaction that happened a few moments ago. Radon, barium chloride. You wrote this one now, so write quickly, and above that you write the formula with starter, Ba2 plus Cl1 minus. So 2 will go at the back of Cl plus sodium sulfate. So you write here a little bit below the plus. You've done this a few moments ago. Sulfate. So Na and SO4 2 here and 1 Na plus 1 valency 2 can cancel, 2 go here, and it gave you this Ba go here. So barium sulfate, a little bit below the arrow you write, and write the formula above it yourself with starter. Yes, Ba2 plus SO4 2 minus 2 cancel, so that's the formula. Na go here, so Cl. So Na and Cl means Na is sodium ion and Cl is chloride ion, so sodium chloride. Na1 plus Cl. We balanced and Ba1 beyond Cl2, and here 1 only, so put 2 here to make it equal to Cl2Cl. Next Na2, 2 Na balance, S1 O4, so this is balance. Now let us see here. There are indivisibles. Point number 2 is saying indivisible and cannot be created or destroyed. Let us see whether that's true or not. Write down here atoms on left hand side. What are the atoms? Please tell me. What is this? Yes, barium atom. Then 1, 2, chlorine atom. Not the number of atoms, type of atoms. Okay, so the third type of atom here found on the left side, sodium atom. Fourth, sulfur atom. The fifth, oxygen. 1, 2, 3, 4. Only these 5 atoms types are found on the left side. On the right side, what are the atoms? First, number 1, barium, yes. Then 2, sulfur. 3, oxygen atom. Sodium atom, Na. And again, only 5 types. Now see whether any new atom is formed or not. Match up, BA, Cl, Cl, Na, NaC. Just cross like you used to do in lower classes. See, and then here. So whatever atom is there on the left side, that type only is found. So no new atom is created on the right side. Even though new substance is created in a chemical reaction, no new atoms can be formed. Means atoms cannot be divided, no, and no new atom can be formed, and no atom was found missing on the right side that was not on the left side, missing on the right side that was on the right side, on the left side, sorry. Meaning ki ase itu bi ide ase do mane left side ki thaki je tu ekta bi hara na do, so atoms cannot be destroyed, no. Did you get it? So now you read once. Atoms are indivisible. That's why 5 types of atom left side and 5 types of atom on the right side. That's why it could not be divided. Indivisible means same atoms are there on the right side, which cannot be created nor destroyed. So we didn't find any new atoms here. Any created means we didn't find new atoms. Destroyed means purana atom ekta bhi hara nahi, so not destroyed. So I hope you got that. And point number 3. Okay, let us read once before we go there. Point number 3 is here. Atoms of a given element are identical in mass and chemical properties. So to explain that, let me just write this one. Let us take 2 substances. Substance, or better use the word compound. Some compound 1, sodium chloride, the NaOH you eat. And then you take here compound 2, sodium carbonate. Now both of them contain one same type, sodium and sodium atom. So take out this sodium atom from NaOH that we eat every day. Take out this sodium atom, and then you react this one with oxygen. You always get a substance, white substance, color substance called sodium oxide. Okay, then balance it. Na, 1, 2 here. Wait, O2 here, 1. At the back you cannot balance, so put 2 in front. 2O or 2. 2 2s are 4 Na, so here you put 4. So this one also you do. Now react this one very quickly, react with oxygen to give you sodium oxide. So this will be 2 to balance this, 2 2 4. So we found out that this 2 sodium were taken from different substance, meaning this sodium was taken from sodium chloride and this sodium was taken from sodium carbonate, different substance, but they are behaving same. Both of them are producing the same substance, sodium oxide. Sodium oxide means their chemical property is same, no. So that's what is meant by point number 3. Atoms of a given element are identical in mass. I'll tell you that not yet. Chemical properties. See, both of them react with air to produce sodium oxide. Even though they are taken from 2 different substances, they are same element, sodium. So they will have same chemical properties. See here. And then mass, same mass, they say. So now you take this sodium again. Okay, sodium from the first one. You take the sodium, take out the sodium from NaCl, and then take the sodium from the next compound we took, sodium carbonate, and you find the mass of the Na from NaCl. Mass of Na in NaCl will be, go to page 37 of your textbook here, sodium 23 grams. That means now this sodium is different. It is not different, sorry, taken from a different substance. This sodium is taken from sodium chloride, this sodium taken from sodium carbonate, this one. So mass of this sodium taken out from a different substance, sodium carbonate, is also the same again, 23 grams. So even though the elements may occur in different substance, they will always have the same mass. That's what Dalton's third point is saying here. See, let's read once more. Atoms of a given element means same element, sodium, sodium, even though they are from different substance, are identical means same in mass, just now we saw, and chemical properties. Both of them produce sodium oxide on reacting with oxygen, have same chemical properties. I hope you got that. And point number 4, atoms of different elements have different masses and different chemical properties. Okay, so let us prove that one. Different, same element have same mass, same chemical properties. Different, so this will be true. Different element will have different mass, different chemical property. So 4 is opposite of point number 3. So let us take point 4. So here, let us see this one. Different masses. Okay, so here hydrogen. Okay, let us take here one element, that is atoms of different elements have different masses and different chemical properties. Okay, so you can take here atoms, one sodium atom and gold atom. This is gold, Au, and sodium, this is. So let us see mass of sodium, 23 grams. Now just now we did mass of gold, or let us say so let's take chlorine. So for example, chlorine atom. Okay, mass of gold. Or okay, calcium atom. Let's take a common one so that you find it easy. Okay, calcium. Instead of this, okay, point number 4, let us do once more. Sodium atom, you take one element and a different element, calcium atom. Now this one, mass of sodium, how much? Go to page 37 of the textbook. 23, so you write 23 grams. So sodium has got 23 gram mass. Then mass of calcium, go to your page 37 textbook again, 40 grams. So clearly they are different mass because they are different. So that's what it's saying. Different element will have different mass. Okay, no two different element will have same mass. That's what the point number 4, Dalton's atomic theory said. So that's correct. And then they will have different chemical properties. Now sodium will react with oxygen to give you the white powder, sodium oxide. As we did just now, I will not explain the balancing like this. But calcium will not react with the same substance. It does not react. So chemical behavior is different because they are different elements. That is what point number 4 is saying. Atoms of different elements have different masses and chemical property also different. Point number 5, atoms combine in ratio of small whole numbers to form compounds. So point number 5, take some compounds. Let's start with simple one, water, H2O. What is the ratio of H is to O here, the two atoms? It is in the ratio of here 2 atom of hydrogen combined with 1 atom of hydrogen only. Take another compound which is very common, carbon dioxide. Okay, here what is the ratio of carbon atom to oxygen? 1 is to 2. See, 1 carbon atom combined with 2 oxygen atom. So the ratio is 1 is to 2 here. The third one you take, let us say sodium chloride, then we eat. I'm just taking simple ones. So what is the combination of sodium atom to chlorine atom? It is 1 is to 1. So you take hundreds of compound like that, you'll always find that the different atoms that combine to form a compound or substance are always in small whole number ratios, 2 3, meaning it means 30 is to 20 like that. It will not come out small numbers, 2 is to 3, 3 is to 4, 5 is to 6 like that, small whole numbers, and not decimals. Also simple numbers, simple whole numbers. That's what is meant by atoms combine in the ratio of small whole numbers to form compounds. Small whole number ratios to form the compound water, to form the compound carbon. I hope you got it. Last point in Dalton's atomic theory is here. The relative number and kinds of atoms are constant. in a given substance, compound especially, okay, or element also. Relative number and kinds of atoms are constant means in a given compound means point. This is just repetition, I think, but then it's okay. Repetition of point number 5 only, but then it's okay. Relative number of atoms combined are constant in a given substance means just take a substance again, 5C. Same explanation. So in water, always 2 atoms combined with 1 oxygen atom. Never 3 combined with 1 or 3 combined with 2. Always same. Any water in China you take, or in India or Africa, you'll find that water is same. That is 2 hydrogen atom combined with 1 oxygen atom, always everywhere in the world. Okay, that's the meaning. Carbon also, carbon dioxide also, 1 atom of carbon always combined with 2 oxygen atom. You will never find carbon dioxide gas where 1 atom is combined with 4. Impossible. Water some places H2O2, not like this. Always H2O means 2:1, not 2:2. That is what is meant by the relative number and kinds of atoms. Kinds of atom means in water you'll find only hydrogen and oxygen. You will not find carbon atom. The kinds of atoms are always fixed. And then relative number is constant, means always 2:1, never 2:2 or 1:4 in carbon dioxide. I hope you understood that. Okay.